Okay, so let's start our session. So from this session, we will start behavioral modeling in Verilog. So in structured procedures, there are two structured procedural statements in Verilog. One is always and another is initial. So the statements are the two most basic statements in behavioral modeling. So the statements are the two most basic statements in the behavioral modeling. All other behavioral statements can appear only inside this structured procedural statements. So statements, all the behavioral statements can be used only in this structured procedures. So what are these structured procedures? So we have two structured procedures. One is always block and another is initial block. So all the behavioral statements are used inside this always and initial blocks. All the behavioral statements are used inside this always and initial blocks. So Verilog is a concurrent programming language, unlike the C programming language, which is sequential in nature. Activity flows in Verilog run in parallel rather than in sequence. So if we see the C language, it is sequential in nature. C language is sequential in nature, whereas Verilog is concurrent in nature. Verilog is concurrent in nature. Concurrent means, so let us understand the difference between the sequential and concurrent. So sequential means, say this is statement 1 and this is statement 2. Here also we will take statement 1 and statement 2. This is statement 2. This is the example for concurrent. So in case of sequential, every statement will get executed in sequential steps. After statement 1 executes, the statement 2 will get executed. Whereas in concurrent assignments, whereas the concurrent means statement 1 and statement 2 will execute parallelly. Here in this case, it will execute sequentially. So this is the difference between the sequential and concurrent statements. So concurrent statements will execute parallelly, whereas sequential statements will execute one after the other. So C language is a sequential language and Verilog is an concurrent language. That is, all the statements will execute parallelly. So Verilog is a concurrent programming language, unlike the C programming language, which is sequential in nature. Activity flows in Verilog run in parallel rather than sequence. So all the statements in the Verilog will run parallelly rather than sequentially like C language. So each always and initial statements represent a separate activity flow in the Verilog. Each activity flow starts at the simulation time 0. The statements always and initial cannot be nested. So all say whether always or initial statements, these two statements will start at 0 time unit. So these both will start at 0 time unit, and each activity flow starts at 0 time units, represents a separate activity flow in Verilog. So the statements always and initial cannot be nested. We cannot use initial within an always block or initial or always inside an initial block. We cannot nest it. So let us start with the initial statements. So all the statements inside an initial statement constitute an initial block. An initial block starts at 0 time unit, executes exactly once during a simulation, and then does not execute again. So coming to this initial statement, so coming to this initial block, the keyword for initial block is initial, and if there are multiple statements in this initial, then we will use begin end statements. If there is only one statement which is written inside this initial, then no need of using begin end. If there are multiple statements, then we will use begin end inside this initial. So when we use initial begin end, then this initial block will be triggered at 0 time units. So this initial block will be triggered at 0 time units, and this initial block is executed only once. This is executed only once during the simulation, only once during the simulation. And all the statements inside this initial block will be only executed only once during the simulation, and this initial block will be triggered at 0 time units. So if there are multiple initial blocks, each block starts to execute concurrently at time 0 time units, and each block finishes executing independently of other blocks. So if in our module there are say initial, this is one initial block, let's say I'm using begin end. This is one initial block in my module, and this is second initial block, begin end. So as we have discussed, Verilog is a concurrent language. Verilog is a concurrent language. So each initial block will work independently and parallelly. So these two are independent to each other. These two initial blocks are independent to each other and they run parallelly. So each initial begin end block is independent to each other, and these two blocks will run parallelly, and these two initial blocks will start at 0 time units. So this is the case when there are multiple initial statements in our model, and if there are multiple initial blocks, each block will start to execute concurrently at time 0, and each block finishes execution independently of other blocks. There is no dependency between the two initial blocks, and multiple behavioral statements must be grouped typically using the keyword begin and end. We have already discussed that if there are multiple behavioral statements, then we will use begin and wait a minute. So if there are multiple behavioral statements, then we will use the keyword begin end to group all these statements. So these two initial begin end blocks will work independent to each other, and they are parallel to each other. So if there is only one behavioral statement, grouping is not necessary. We have discussed it. So if there is only one behavioral statement, so within initial, if there is only one statement, then there is no need to use begin and end. So all the statements which are used in behavioral modeling are called procedural statements. So all the statements which are used inside this always block and initial block, these statements are called as procedural statements. Whereas in case of data flow modeling, whereas in case of DFM, the statements are called continuous assignment statements. So this is the difference between these two statements. So the Statements which are used inside the behavioral, inside the procedural, inside the behavioral modeling are called procedural statements, and which are used inside the data flow modeling are called continuous assignment statements. So this is about initial beginning blocks. And coming to always blocks, all the behavioral statements inside an always statement constitute an always block. The always statement starts at time 0 and executes the statements in the always block continuously in a looping fashion. So let's consider an always block here. So if we have multiple statements, then we will use begin end. If we have multiple statements, multiple procedural statements, then we will use begin and block. Or else if we don't have multiple statements, if we have only one statement, then there is no need to use begin and block. There is only one procedural statement. Then there is no need to use begin and block. And this always block is like a loop, so it will go on running during the simulation. It will go on run during the, it will run entirely during simulation. So until the simulation ends, the always block will go on running, whereas initial block will start at 0 time unit and it will only execute one time, whereas this always block is like a forever loop. It will keep on running until the simulation ends, and it will start at 0 time unit. So this is the important point to remember. And all the behavioral statements inside an always statement constitute an always block. The always statement starts at time 0 and executes the statements in always block continuously in a looping fashion. And the statement is used to model a block of activity that is repeated continuously in the digital circuits. So the statements, the procedural statements which are declared inside the always block will run continuously, throughout the simulation. For example, in our previous sessions we have discussed, while we are writing the test bench, for generation of clock, I have used this always block. Say suppose if I want to generate a 10 nanosecond 10 time unit clock, then I will use always hash phi clock is equal to not of clock. So basically this statement will be executed throughout the simulation. It will run throughout the simulation forever. So this is like a forever loop. So for first 5 time units clock will be equal to high, and next 5 time units clock will be equal to 0. So like this always block will be go on executing throughout the simulation. Wait a minute. So this always block will start at 0 time units and it will go on run for entire simulation. So this is always block. And coming to initial block, it will start at 0 time unit and it will run only for one time, So this is initial block and always block. And procedural assignments. So coming to procedural assignments update values of reg, integer, real or time variables. The value placed on a variable will remains unchanged until another procedural assignment updates the variable with a different value. So let's see the procedural assignments now. So is this clear about always block and initial block? Is there any doubt? If you are having any doubt, you can ask me. So this is a behavioral modeling, in this behavioral modeling, I'm using a procedural block. So this initial beginning block is a procedural block. So this is a procedural block, and the statements which are used in this procedural block are called procedural statements. And the assignments which are done in this procedural block are called procedural assignments. So I will make a procedural assignment now. Initial, begin. No need to use begin and if there is only one statement, but I am using begin and for one statement also. So let's say we have declared a reg, say A. So in the procedural assignments, so in a procedural block, we can use only reg data type. Init data type is not allowed in procedural blocks. So I am using this reg data type and I am assigning a value of 0. So the assignments which are done to this variable in these procedural blocks will remain unchanged until another value is assigned to this variable. So a will be equal to 0 until the value of a gets changed. So here a will be unchanged until value of a gets changed. So this is the statement which they have written here. So the procedural assignments update values of reg, integer, real or time variables. The value placed on a variable will remain unchanged until another procedural assignments updates the variable in a different value. So the data types which can be used inside the procedural assignments are reg, integer, real and time variables. We cannot use wire variables inside this procedural blocks. We cannot use wire data type. We can use wire data type in continuous assignment statement, continuous blocks. So these are about initial, beginning block and always blocks and procedural assignments and procedural blocks. So in summary, we have in Verilog we have two types of statements. First one is continuous assignment statements, which we have discussed in data flow modeling. So we have continuous assignment statements and another we have procedural assignments. So continuous assignments are done inside the blocks, continuous assignment blocks, and procedural assignments are done inside procedural blocks. So in case of continuous assignment statements or continuous assignment blocks, we will use a keyword assign. So if there is a keyword assign, then it is a continuous assignment block, and the value, say suppose assign a is equal to 0 or a is equal to b, then the value of a will be changed whenever there is a change in value of b. And in case of procedural assignment statements, we have initial and always. Initial and always both start at 0 time unit. Initial will run only one time during the simulation, whereas always will run forever until the simulation ends. And the data types which can be used inside initial and always are time, reg, integer and real. So the assignments which are done inside this procedural blocks are called procedural assignment statements. So this is the introduction and summary to procedural assignment statements and procedural blocks. So if you are having any doubt, you can ask me.